So good morning to all. If you're in the middle of the U.S. and eastern U.S., western U.S., but to my friends in the Middle East, good evening, late afternoon, actually, early evening. Really appreciate everyone taking some time out of their busy schedule to be part of this FCIA DIIM webinar, Firestop Level 1 education program. Really glad that you've taken some time out of your busy schedule to be with us. The program consists of covering D, I, M, and M, the design, installation, inspection, and then maintaining protection of fire resistance rated assemblies through FCIA's DIIM strategy. Before we get started, a big thanks to the FCIA members for your membership and also for all the work that you do all day long. We really appreciate the FCIA members, because without your dues, we can't do what we do. So thank you from the bottom of our heart for being an FCIA member, the Firestop contractors, the manufacturers, distributors, manufacturers reps, and of course the inspection agencies and the friends of FCIA. Thank you. To those specifiers on the line, and then also those authorities having jurisdiction with jurisdictions, a free FCIA manual of practice, a PDF of that manual of practice is available to you free of charge. Email info@fcia.org to get your free copy. We do that as a service to the industry and a service to fire and life safety. The Life Safety Digest magazine, the magazine of effective compartmentation, fire resistance, if you will, is a document that's available quarterly that we continue to publish and provide as a service to the industry. We also appreciate the writers and advertisers of Life Safety Digest, because they provide the funding for us to do what we do with that magazine and circulate it to those important entities that need it: Firestop contractors, manufacturers, authorities having jurisdictions, specifiers, building owners and managers, fire inspectors, and more. The FCIA also has, over the years, taken its DIIM philosophy that was started 20 years ago with the association's formation and built programs that you'll hear about today, inspection standards that you'll also hear about today. And there's many, many tools at fcia.org for you to use that are open and free to all. The FCIA believes in this concept of total fire protection, effective compartmentation, including the fire barriers, firewalls, fire separations as they're known in Canada, fire walls and horizontal assemblies, smoke barriers, smoke partitions, fire partitions. We believe that those fire resistance rated assemblies that are protected with the breaches that are protected by fire stopping, fire dampers, swinging and rolling fire doors, fire rate glazing, and much, much more. Plus the detection and alarm systems, sprinkler systems, and education, of course, of the occupants, as well as the building owners and managers for safety. For the firefighters, for the building occupants, education is critical. How do you get out of your space safely? How do I get out of my space safely, regardless of where I am, whether I'm at home, a restaurant, a conference? It's my responsibility to know my two ways out. That's part of the education process that's required for the DIIM's total fire protection process. So what is the DIIM? It consists of proper design, specifications, codes, and standards. The codes and standards communicated through the specifications, in other words, the construction documents, to the construction community that provide the basis for construction. The installation to the tested and listed systems designs, manufacturer's installation instructions, with manufacturer education, we hope, to make sure that those products are installed to the tested and listed systems design and the manufacturer's installation instruction. We also hope that it's FM and UL qualified contractors that have a management system that's been audited by that third party. Inspection to the ASTM E2174-2393 standards that are required by the International Building Code in Chapter 17. We'll show you where that is later. And also for the rest of the compartmentation assemblies, NFPA 80 lays out the installation, inspection, and maintenance protocol for those other fire resistance items, fire dampers, fire-rated doors, fire-rated glazing, and more. NFPA 1 lays out some information as well for that. We'll get into that too later on. Then, of course, maintaining protection through barrier management. The fire codes, both NFPA 101, NFPA 1, and the International Fire Code, the UAE Fire and Life Safety Code, the National Fire Code of Canada, all lay out maintaining protection for the life cycle of the building. The DIIM can be used for each one of these disciplines. In this slide, I've chosen to stick with just fire stopping and lay out the test standards that provide the proper design, installation, inspection, and maintenance of fire stopping. First, a good specification. Our friends at Master Spec Inspect Link at the CSI agree that a single specification section 078400 for fire stopping makes most sense. Say it once, say it one place. Don't conflict from one construction discipline to the other, from one specification section to the other. Say it in one place and then refer back over to it. So all the other sections, mechanical, electrical, plumbing, wallboard, concrete block, should all be referring back to section 078400, where all fire stopping is specified. When I say all fire stopping, I'm talking about fire stopping for penetrations, fire resistive joint assemblies, perimeter fire containment assemblies, bottom of wall systems, head of wall systems, all the fire stopping that would be included in that. The test standards for all of these that are referenced in those specifications as dictated by the building codes, and in some cases not dictated by the building code, but chosen by the specifier. For instance, the ASTM E2837 is not yet in the International Building Code. Yet the specifiers know that there's a test standard for proving suitability for use of the products in a specific application. So that 2837, which is for the head of wall of a non-rated roof assembly to a rated wall assembly, the continuity head of wall assembly, they know that standard exists. And that's the closest approximation that we have to extending that fire resistance rating to the next assembly. ASTM E814, UL 1479, the ASTM E1966, the UL 2079, ASTM E2307, the new ASTM E2874, and of course E3037. We'll talk about those later on. So standards communicated by the specification from the building codes, or because the specifier believes that it's the appropriate thing to do. Professional installation, of course, by FCIA member ULC qualified contractors and UL contractors, or FM 4991 and FM 4991 approved contractors. We'll talk about those later. And of course, properly inspected by inspection agencies, hopefully accredited to the IAS AC291, to the ASTM E2174 and ASTM E2393 inspection standards. We hope the individual inspectors have passed the FMUL or the International Firestop Council exam, and in our opinion, and the International Firestop Council exam. Why? Because the UL and FM exams have been the industry basis for testing technical knowledge for decades. Also, inspection questions, installation questions, both are on these exams. And it's important that the inspection agency know what the installation company is thinking and what their education is to be able to come from the same spot when looking at them. And of course, the protection maintained annually by FCIA members is our opinion that are part of the Barrier Management Services section of FCIA.org. So let's get into the details and talk about the DIIM, starting with the D for design and codes, specifications, and standards. The first thing is the International Building Code and other codes lay out the minimum benchmark level of safety provided by provided to the specifier, and then also to the building owner and manager, the minimum level of safety they have to provide the occupants and visitors in those buildings. Where do we find fire resistance? We find it in Chapter 7 of the International Building Code, Chapter 7 of the International Fire Code, Chapter 8 of NFPA 101 and NFPA 5000, You'll find it in Chapter 3 of the National Building Code of Canada, and then the UAE Fire and Life Safety Code of Practice over in Chapter 21. They set the minimum requirements for construction and maintaining protection. The first thing that takes place is that fire resistance is determined. The test standard that I have highlighted in yellow, the ASTM E119 UL263, and then other standards around the world similar to it, lay out the benchmark for all the other pieces of fire resistance. This standard, celebrating its 100th anniversary last year, ASTM E119, has been around 100 years. And it is the acceptance criteria specified in ASTM E119 that sets up the fire exposure for a building element, a component, or an assembly for fire resistance. So the E119 UL263 is the charging language, if you will, for determining fire resistance of the assembly. The building code, the International Building Code in section 7033, gives several different options for determining fire resistance. The first one is fire resistance designs documented in approved sources. An approved source is the Product IQ UL Fire Resistance Directory, also the Intertech Directory, and the FM Approval Guide. That's where we'll find, along with, of course, other laboratories that run that, Thomas Bell Wright, our friends in the Middle East, and many others. But the fire resistance designs documented in approved sources, that ASTM E119, as it's laid out, is a large-scale test, not small scale. Large scale meaning the size of a room, basically. Big, huge furnace with a load applied and burned for a period of time with a time temperature curve. But the first method, fire resistance designs. Second method is prescriptive designs of fire resistance rated building elements, components, or assemblies as prescribed in section 721 of the International Building Code. And those prescriptive designs probably have some furnace testing that took place decades ago to determine whether or not those are acceptable by the building code. Third, calculations in accordance with section 722, the calculated method for determining fire resistance. Fourth, engineering analysis based on comparison of a building element, component, or assembly, having fire resistance ratings as determined by test procedures set forth again in ASTM E119 UL263. And then, of course, alternative protection methods as allowed by section 104.11 of the building code. That's where the performance-based design would take place. There's been a lot of discussion about performance-based design over the years and its use in buildings. For structural fire resistance, it seems appropriate. Those that are at the American Society for Civil Engineers debating a performance-based structural fire design have stated that for compartmentation purposes, performance-based design is not acceptable. It's only for the structural part of fire resistance design. Finally, fire resistance designs certified by an approved agency. Back to the UL Fire Resistance Directory. So as you can see here, it's very clearly laid out in 4 different places that fire resistance be determined by tests as well. So here's the standard time temperature curve that you would find in ASTM E119 UL263 that also is the same time temperature curve in the furnace that you would find for fire stopping, fire dampers, fire-rated doors, and fire-rated glazing. It's basically the same time temperature curve. For all vertical assemblies, regardless of which type of fire resistance it is, it's going to get a hose stream test when tested in accordance with ASTM E119, UL263, and then, of course, all the other fire protection features that protect the breaches, fire dampers, fire-rated doors, fire-rated glazings, fire stopping, and fire-resistive joint assemblies. One thing in the building codes, a question that constantly comes up in the fire stopping industry, discusses something called labels. Labels are not mandated by the International Building Code for fire stopping, but they are mandated for the fire resistance rated assembly itself in the International Building Code. The FCIA worked with the code proponent to alter what was here. It initially was put in by Sean DeCrane at the time with the Cleveland Fire Department a captain with the Cleveland Fire Department. It was then updated by Valerie Evans, North Las Vegas code official, who took this section and instead of just saying stencil it or write it, laid out the method for writing the identifying the wall itself, if you will. That it be located in an accessible concealed floor or floor ceiling or an attic space. That it be located 15 feet from the end of each wall. And that lettering be not less than 3 inches high, 76 mm in height, with a minimum 3/8 inch stroke, as well in contrasting color, incorporating the suggested wording that's below. Nfpa 101 has had code proposals to not only do this, but also to mark the barrier as it's identified by the building code. So that would mean mark the barrier as a fire barrier, smoke partition, fire partition, or firewall. Why is that important? Because the treatment of those assemblies differs when the type of barrier changes. A smoke barrier would get an L-rated Firestop system with a certain L rating to it. A smoke partition would get a smoke and sound sealant, as the manufacturers have stated. Marking with defined terms, that's a good code proposal for the 2024 version of the International Building Code, which is due sometime in January. It's interesting, our friend Stuart Tom from the state of California, a code official now retired, brought with him a sign to one of our conferences that showed us how wide the markings would be if using the stroke height and width. And if you look at it, it's a span of about 6 feet, 914 millimeters side to side for the marking itself. So thanks to our friend Keith Heckler for the slide and for the information of what it looks like, and Stuart Tom for giving us the graphic of it. And as mentioned earlier, NFPA 101, the Life Safety Code in Section 8225 of the 2018 edition, requires that the barrier be marked and identified as it is named by the building code or the fire code. So now that we know fire resistance is required in buildings, it's marked. How are they determined? How do we know where those walls are? Table 601 in the International Building Code lays out where those barriers are going to take place. The specifier, the designer, working possibly with a fire protection engineer, lays out the compartments that are required by the building code for that type of occupancy. The multi-family residential occupancies, healthcare occupancies, hotels, and others will have a lot of compartmentation with it all marked on the architectural plans, the life safety plans, so that we know exactly where it is that fire stopping is to be applied. That comes from Table 601 of the International Building Code. Once the fire resistance rated assembly is built and on the structure, then what do? How do we protect it? Because we know there are breaches made in that fire resistance rated assembly to accommodate service items, bringing air to certain parts of the building, bringing gases to parts of the building, communications, electrical, various liquids that need to flow through piping that go from one end of the building to the other and cause breaches in the fire resistance rated assembly so the penetrating item can continue onward through the structure. Those breaches need to be protected. The continuity of fire resistance has to be continuous through that breach from outside wall to outside wall, from floor ceiling to floor below. That's what the building code asks for, continuity of fire resistance. And to make a point, it doesn't ask for sealing a pipe, it asks for continuity of fire resistance. As soon as that continuity of fire resistance comes in, that takes us to the tested and listed systems that you see below, the standards. The U119 UL263 for the wall or floor of the fire separation. And then the various protection pieces, fire stopping, all the test standards you see below that we'll go through. The swinging and rolling doors, tested to UL10B and C and FPA 252. the fire-rated glazing to UL9, ASTM E119, or UL263, depending on the type of assembly, glazing assembly it is. Is it a fire protective assembly or a fire resistance rated assembly? It matters because fire protective might not protect against radiant heat going through that fire-rated glazing, whereas fire resistance rated glazing would. And then fire and smoke dampers, tested to UL 555 and 555S. Totally different test standards. But again, as soon as we start talking fire standards, it all has the same furnace test, basically. A large furnace, in some cases, as large as 10 feet by 10 foot, if you will, 3 meters by 3 meters, just about. And penetrations are put through it. Fire dampers might be put through that assembly, glazing, full-size doors, and other items as well. But the system testing is really the suitability for use statement of the products in the specific applications. So let's take a quick look at some fire resistance rated assemblies. Take a look at this one. It's a concrete block wall with 2 copper penetrating items passing through a breach in a concrete block wall, and it's labeled. The key thing on that label, the Firestop label, which is not required by the building code, by the way, it's a code proposal the FCIA will do for the 2021 version of the, 2024 version of the International Building Code. But note that the label has a spot on it for the system number. That system number aids the inspection agency in knowing what system to inspect, aids the building owner and manager to know what system is installed in that assembly, because in the system, once they look it up, the building owner, manager, or the inspector, in that system number is the description for what took place with this particular Firestop assembly. It'll state what size that copper penetrating item can be. It'll state how big the annular space can be between the sleeve and the penetrating item's pipe insulation. It'll identify what type of pipe insulation it might be. Fiberglass, mineral wool, calcium silicate, even some of the foams that might be there, whether it's a rubber Armaflex type foam or some of the polyisocyanurates or phenolic-based foams. All of that would be specified in the tested and listed system. That's why those labels are so important. Call it a drain the swamp exercise in management. In other words, don't fight the alligators. In other words, having to look up every system and reverse engineer to figure out which system it is, put a label up on the wall, and it's very quick to identify what those systems are, and eliminates a lot of time on a lot of people's parts. So when you say eliminating time, the inspection agency doesn't have to go look it up. The building owner manager doesn't have to go look it up. The company that's servicing the barrier management services company, they don't have to look it up either. So looking at some of these systems, and I'm going to go into it in greater detail in a couple of minutes, looking at these systems, CAJ 5138, CAJ 5209, WJ 5091, if you think about it, looking at these systems, there's a lot to them, and there's a lot of detail to it. There are many in the construction industry that believe that all we need to do for fire stopping is stuff some brown fibrous material. We know it as mineral wool, or in other parts of the world, rock wool, and then install some Firestop sealant, or as the uneducated call it, fire caulk, and make it look good. Well, that's the easy part. The hard part is identifying the systems for these particular applications. So let me go over and see if I can grab a few systems and start looking at what we have here. So let's pull up this system and go back to what the system is that's on the slide, CAJ 5029. The CAJ stands for something, and I'll go through that in another webinar. The CAJ would be a wall or a floor, certain thickness. The 5029, the 5 series being insulated penetrating items. 029 being the 29th in the series for that particular application. Scrolling down, we can see that CAJ 5029 has an F rating of 3 hours, fire resistance rating of 3 hours, a T rating, temperature rating of 1 hour, and then in the ULC S115 got FT, FH, and FTH. That means it identifies that it does have the host stream test. And then let's take a look at the picture. Looking at the picture of this particular item, it doesn't seem to show a sleeve as we had seen in the picture earlier on. So let's scroll down and see what the assembly is. It shows a 4.5 inch thick reinforced normal weight concrete or any UL classified block. So any classified block could be any thickness as long as it's a UL classified block. And there we're okay. Maximum diameter of the opening seems to be about 12 inches. That picture that I put up earlier looks like it as well. Then it shows a steel pipe, nominal 6-inch diameter, schedule 10 steel pipe to be centered within the Firestop system. And then it asks for a pipe covering of 2-inch fiberglass. Then it's going to show a packing material, not shown and optional. In this case, 2 inches of 6 pound per cubic foot mineral wool back insulation packed into the opening, recessed to accommodate the sealant. In this case, it's showing 2-inch thick fill material applied within the annulus, flush with top surface of the floor or both surfaces of the wall. Just know that I'm showing this example as an example. We know that the manufacturers have optimized and gotten very thin with the Firestop sealants, and you can bet you'd find a system that's a lot thinner than 2 inches thick for this particular application. May or may not, just depends on the assembly. But what's missing? Looking at the picture again, it had showed a sleeved application, as we can see here. So 5029 is not right, but maybe 5209 is. So let's look at the 5209 again and see what we can come up with. The 5209 in this case shows a steel sleeve, 9-inch or smaller, cast or grouted into the floor wall assembly, and then it's installed flush or can project 2 inches past the wall assembly or the floor assembly. Now we're looking like we're doing just okay. The concrete block, again, in a UL classified, through penetrating items, 1 metallic pipe installed concentrically or eccentrically within the opening, and this one, if I remember correctly, they were showing it offset a bit. And then the steel pipe, iron pipe, copper pipe, looked like all the penetrating items were correct. The pipe covering, in this case, it allows a 1 1/2 inch, 38 mm or less glass fiber units. It looked like fiberglass insulation to us. And then in this case, the T rating is 3/4 of an hour for a nominal 1 1/2 inch thick pipe covering. And then 1 hour for certain penetrants, C and D. C and D meaning the iron pipe and the copper tubing. So it looks like the assembly that we showed previously really does match up to what we saw in this particular application. That's what makes fire stopping complex. We see advertisements all the time that talk about it's easy to install this fire stopping. Easy to do this, easy to do that. It's not easy to do anything. I know it takes me 3 trips to the hardware store on a Sunday or a Saturday or a Friday to make sure I get my project correct. Imagine a complex hospital construction and the amount of coordination and knowledge base required by all the different construction disciplines to get that facility built properly. Moving on, the building and fire code requirements really dictate why we need fire stopping and where we need it. The specifications will call for systems, just like I went through, and they state that the Firestop contractor is to select those systems and then communicate the documentation to the workers in the field to make sure that those systems get installed to the test and listed system design and the manufacturer's instructions. That 078400 section communicates very clearly to the Firestop contractor. So it goes from the code, building code, to the architect specifier, to the contractor. and installation worker through the construction documents, that 078400 specification plus the life safety drawings, that then specifies products, but also specifies systems. Select the systems that are appropriate and return the floor and the wall to the fire resistance rating it had before a breach was made to insert a penetrating item, and then make sure that the physical properties of the products resist the environment to which it is installed. We'll get into that in a little bit too. Then it'll also list in the specifications some of the acceptable manufacturers. When it comes to engineering judgments, we'll talk about them later on. The specifications typically state that a single manufacturer is to be used to the greatest extent possible. That sets up the FCIA's Engineering Judgment Protocol, the International Firestop Council's Engineering Judgment Protocol, and the protocol from the Manual of Practice, the Firestop Manual of Practice. It says, use a tested and listed system first, and if you can't find a tested and listed system in the directories from all over the place, from another manufacturer other than what was submitted on the project, then look for an engineering judgment or equivalent fire resistance rated assembly. Key parts of the specifications include the contractor installer qualifications. In specifications, wherever it says installer, it really means the Firestop contractor, because in the specification language, the installer is the subcontractor. The contractor is the general contractor. When it comes to the installer qualifications, it talks about the company qualifications. In many cases, it states FCIA member in good standing, FM 4991, approved Firestop contractor, UL qualified Firestop contractor, and maybe manufacturer accredited, approved, or trained as well. Key elements for the contractor. It also will specify in Part 2 qualifications, the qualifications required for special inspection. Special inspection is a term from the International Building Code. That's where the ASTM E2174-23993 standards get invoked by specification. The qualifications for the inspection agency and the inspector must be specified in the 078400 specifications. Under the 078400 spec, it might require an IAS, International Accreditation Services, AC, Accreditation Criteria, number 291, Accredited Special Inspection Agency. The Special Inspector also has some qualifications. We'll go through what those are, but we believe it should be someone that's passed the FM UL Firestop exam and the International Firestop Council exam. Under execution, it'll call for the ASTM E2174-2393 to be for inspection of certain types of buildings. And we know that will help result in the proper DIIM. This part, the 017839 specification, accounts for the M. So we talked about the D, the test standards, which we'll get into a little bit more detail in a couple of minutes. The I and the I, inspection, installation and inspection standards, and now the M, all through the 078400 specification and also through the 017839 project record document section. Those project record documents in 017839 are needed to maintain the fire resistance protection provided by fire stopping and other items. The 017839 specification would point back to 078400 for the project record documents. What that means is that the test and listed systems, the manufacturer's installation instructions, the listings, the life safety drawings, the safety data sheets, all would be assembled in a packet by the general contractor that would be provided by the Firestop contractor to that general contractor, and then passed on to the building owner and manager for managing and maintaining the protection of the building for the life cycle of the building. This is something that's quite important not to forget, that your documentation as a Firestop contractor winds up being the building life cycle documents. So what about barriers? What about fire resistance rated assemblies? What are the terms? Many times we will see terminology that doesn't quite fit the terminology in the building code. For instance, we've seen on project drawings 1 hour fire resistance rated partition, 1 hour fire smoke partition. To me, I'm saying, 1 hour fire smoke partition. Is that a smoke partition or a smoke barrier? Why? Because a smoke barrier carries a minimum 1 hour fire resistance rating with L-rated fire stops in the building code. A smoke partition, 0 fire resistance rating, and limit the spread of smoke. So which is it? If the terminology is not right, then we don't know from the fire stopping angle what we're supposed to provide. Continuity changes too. Fire partitions in some cases may not have to be continuous above the ceiling if there's a hard ceiling used. Again, terminology is very, very important. Exterior walls might have a fire resistance rating. Fire walls, different from a fire barrier. Fire wall meaning maintains fire resistance and structural resistance, such that one side of a building can completely collapse while the other side of the building remains standing, protected by that firewall. The horizontal assemblies on either side of the firewall would be separately supported so that that could take place. Then there's archaic assemblies: clay tile block, gypsum block, plaster, clay tile and concrete, and something you just can't identify. What do we do then? And mainly these are in existing buildings. Why are existing buildings important? Because there's probably many structures where there's been enough changes in the service penetrations, service items that have gone through a building where the breaches might not be protected. There's a lot of places that need to be protected now in existing buildings. Identifying the assembly is the first thing to do in system selection. And the fire stop system treatment might be different once these assemblies are identified. How do you fasten a clay tile block, gypsum block, and plaster? So we can't just simply take a WL assembly that would be used for wallboard assembly and use it for gypsum block, for instance, or clay tile without an engineering judgment from the manufacturer. Back to fire stopping, smoke barriers defined by the International Building Code and Nfpa 101. The International Building Code says that a smoke barrier is a fire resistance rated assembly, continuous from outside wall to outside wall, floor ceiling assembly down to the horizontal assembly below, and it carries an L rating, an air leakage rating, of less than 5 cubic feet per minute per square foot of opening area for each penetration, and then less than 50 cubic feet per minute for 100 square foot of wall area for the complete wall. That is an important point. Why? Because it requires some brains to count up the number of L-rated assemblies, Firestop assemblies, that are penetrating that fire resistance rated assembly in order to provide the building owner or manager what they paid for with the building code. Nfpa 101 has a smoke barrier referenced in Chapter 8 of the Nfpa 101 and Nfpa 5000, but it's not mandated by the occupancy sections in healthcare and such. However, knowing that the quantified L rating is the standard for use in fire resistance rated assemblies, it would make sense that the Firestop contractor would use an L-rated Firestop in that smoke barrier even though the code didn't mandate it, because it's the benchmark level of protection provided by that Firestop system. Smoke partitions are completely different. They're not fire resistance rated at all. 0 fire resistance rating, but want a continuous barrier to limit the spread of smoke, limit the transfer of smoke. What products get used to protect the breaches in these fire resistance rated non-fire resistance rated assemblies. That's where the manufacturers have invented this newer smoke and sound sealant type product that can be used for that type of an application. Can a L-rated Firestop be used for that application? Absolutely, it can be. Those assemblies can be used. Firestop system assemblies can be used for that particular application. So let's get on with the show and talk about the rest of the compartmentation features very quickly. We know that the fire resistance rated assembly is built to a U400 or other U series assembly, whether it's concrete block, gypsum wallboard. If it's a listed assembly, the recipe for building that assembly will be in the UL fire resistance directory, UL product IQ. Note on the left-hand side that all of the joints have been taped and there has been gypsum wallboard compound applied to the fastener heads, as you can see with the little dots that have white spots all over it. And then also the joints have been taped and treated with gypsum wallboard. On the other side of the assembly, the joints would not line up directly with the other side of the assembly. The joints from the other side of the wall would be offset so they don't occur such that you have a joint on the same stud. The joints would be on offsetting studs, and the listing will show the recipe for how that takes place. Look at the bottom of the slide under the wall. In that section, it shows the fire resistance rated glazing assemblies. Those fire resistance rated glazing assemblies provide protection to the wall assembly. And in this case, they're large openings, which would tell us that they're fire resistance rated glazing and not fire protection rated glazing. Fire stopping is in the middle picture, and then fire dampers in the upper right, and of course, fire rated swinging doors on the bottom right. The one picture that's missing is the rolling fire door, probably the largest opening that you will find in fire resistance rated construction. So let's get into fire stopping a little bit more. Looking at the picture on the left, and yes, it's blurry. It's blurry for a reason, because the picture on the left is what happens when you look at the UL directory way too much. That's what happens to me after a day's worth of work looking at the UL directory. Picture on the right shows penetrating items. The object of fire stopping is to take the picture on the right and matching it up with systems on the left. The products become systems once they've been tested and listed to the fire resistance rated test standards that you see here. ASTM E814, UL 1479, that would be the test standard for penetrations. UL 1479 has more optional pieces to it than ASTM E814. UL 2079 and ASTM E1966 are what you would use for joints, head of wall, bottom of wall, floor to floor, wall to wall, and wall to floor. Those joints, fire-resistant joint assemblies, are used to treat those breaches that are made to accommodate movement, independent movement, incompatibility of two wall or floor assemblies, to allow for building sway, thermal movement, or general movement altogether. The ASTM E2837 covers head of wall assemblies, continuity head of wall, where a non-rated roof assembly meets a horizontal assembly. The ASTM E2307 covers perimeter fire containment, where a non-fire resistance rated curtain wall assembly protects the space between the horizontal assembly, the floor, and that exterior skin of the building. The ASTM E2837, relatively new test standard, that test standard covers the leapfrog effect, because the 2307 only covers the interior safing slot. We'll get into that in a little bit. The FM4990 is for penetrations and joints. It's FM's standard, a bit different than the UL and ASTM standards. But take a look at the ratings, FT, L, W, M. The first two are all you'll get with an ASTM E814 test standard, an ASTM E1966 test standard. Fire resistance rating. The L rating, smoke, is part of UL 2079 and then UL 1479. Doesn't mean that UL is the only facility that can evaluate the assembly based on the L rating standard that's in 2079. It just means that UL invented it and it's in the UL standard and not in other standards. W, fire or water resistance. Again, that's in the UL standard and not in the FM or the ASTM standard. M for movement. That one's in the ASTM standards. ASTM E3037 is the new movement standard for when penetrating items move or the assembly moves and the penetrating item stays static. That M standard is a result of an FCIA initiative in 2008 where we wrote a letter to the manufacturers announcing that we would like to see some dynamism, dynamic movement, brought to the penetrating items just like there is for joint assemblies. What are the conditions of acceptance? Thanks to our friend Rich Walke for these good slides that we use to discuss the conditions of acceptance for the F rating and the T rating. In the ASTM E119, I'm sorry, ASTM E814, UL 1479, there's an FT rating, a temperature rating. You have to have a temperature rating, whether it's 0 or not, but it's tested for a Firestop system. First, does it restrict the passage of flame through to the unexposed side of the assembly? And then a 325-degree temperature rise, 180 degrees C, and then, of course, the hose stream test. The optional tests are the air leakage test. The air leakage rate at ambient is measured, ambient meaning about 75 degrees Fahrenheit, and then, of course, at elevated temperatures, 400 degrees Fahrenheit, 204 degrees C as well. The W rating is also an optional program, and it's really there to protect against a small head of water after 72 hours, that it doesn't leak water to the floor below. It was developed based on an architect's call for issues that occurred in super high-rise buildings. Somewhere in downtown Chicago, a sprinkler pipe or a mechanical pipe burst. The next thing you know, we've got water dropping down 10, 15 stories, damaging each floor as it goes. So the architects asked, how can we protect against this? And do you have a solution, Firestop industry? So the Firestop industry did say, yep, we have a solution, and it's using the W rating from the UL 1479. The M rating, movement rating, is relatively new. It applies to the movement of the penetrating item or the assembly with the penetrating item remaining static. It can move in perpendicular or in the plane of the barrier. And then after the test, there's a hose stream test and a fire test that takes place. Same thing with the air leakage rating. So the way these Firestop systems are tested, in order to determine the T rating, there are thermocouples that are installed above the fire test assembly to measure the temperature on the penetrating item a few inches above the horizontal assembly. You can see the thermocouple attached right here where my cursor is, and it looks to be about several inches above the horizontal assembly. The furnace is turned on and the assembly reaches 1,000 degrees in 5 minutes, 1,700 degrees in an hour, 2,000 degrees in 4 hours. It's a positive furnace pressure test, meaning that there'd be a push against the assembly that the Firestop has to resist as well. Then when the furnace is turned off and the assembly removed, a hose stream test is run to see if the assembly has the ability to withstand an impact against it after the fire test has taken place. That impact simulates things falling in a fire, the ceiling tile, the light fixtures, speakers that might be in the vertical or horizontal assembly, other items that might hit the assembly. It's not there for waterproofing, it's only there for structural purposes as well. And then what about chemical, biological, radiation resistance? These are all critical items to check. If you remember earlier on during the specification section, I mentioned that the Firestop system, the products used in that system, sealants, wrap strip, composite sheets, more and more, all have to resist the environment that they're expected to be exposed to. So therefore, it would have to resist chemicals, biological agents, radiation, possibly explosion, possibly germs. Chemicals, what chemicals? Are they cleaning chemicals or are they other chemicals? Biological agents, what about germs? We're not sure. What about radiation? Is there enough radiation that goes through the ceiling tile that could affect the Firestop product? Have the manufacturers tested their products for radiation? Many of them have, because the Firestop industry came from shipbuilding, of course, and then also protecting barriers in nuclear facilities. What about blast resistance? In the 2008, 9, and 10 code development cycles, I served on the ad hoc committee for terrorism-resistant buildings at the International Code Council. Blast resistance was one of the items studied by the ad hoc committee on terrorism-resistant buildings. Why? Because robustness was sought for those critical shafts in those types of buildings. Buildings 420 feet above lowest fire department access, making it a super high-rise building. And as such, the shafts, critical shafts and stairwells, have to withstand a blast of a certain soft body impact tested to an ASTM standard. The question would be, has the Firestop been tested to withstand some kind of resistance to blasts as well, equal to what the wall has? Let's talk a little bit about some of the test standards. The ASTM E2307, for instance, protects the exterior safing slot. The interior safing slot from fire exposure. There are several different flame exposures, one that takes place from below the assembly, aimed at this safing slot where you can see the brown mineral wool, or rock wool, if you will, is generic term that it's called, before the spray goes over the top of it. And it's to protect that interior safing slot for a certain period of time. The leapfrog, where glass breaks out from below, goes up the exterior skin of the building, breaks the glass on top. That's the ASTM E2874, relatively new test standard that you'll hear about in future webinars for leapfrog effect. All of these systems become systems when they've been tested and listed to the fire resistance designs and test standards that we mentioned earlier. Let's take a look at some of these designs so we can start analyzing how they all work and how they fit. Let's move this one over and look at the FM approval guide. How did I get here? I went to approvalguide.com, as you can see in the URL. Then I put in my name and password, because you have to register for these things, and email address. And then I'm in to look at the designs. In this case, it's a wall or floor penetration fire stop approved under FM approval class number 4990. In Firestop Design 199, an F rating of 1 hour has taken place and a T rating of 0 and a TFM of 1. The floor is a minimum 4.5-inch thick normal weight concrete with a maximum nominal 10-inch diameter, 250 mm diameter opening. The penetrating item in this case is a glass penetrating item, not copper, not metal, but glass. It's a maximum 6 5/8 inch, 169 mm outer diameter glass pipe with a minimum wall thickness of 0.33 inches, 8 millimeters. The annular space between the pipe and the edge of the opening should not be less than 5/8 inch, 3/8 inch actually, or 10 millimeter. Pipe shall be rigidly supported. The Firestop components in this case are forming material, in this case a polyurethane backer rod, 1 inch thick, firmly packed into the penetration and recessed a minimum of 3/4 inch or 19 mm, and then a film material, caulking material applied to the opening at a minimum depth of 3/4 inch. And then surfaces are troweled smooth. The product used, Rector Seal, Medicaulk 950 film material at a thickness of, again, 3/4 inch. So that's what a system would look like in this particular application. Let's look at the annular space size. So it says that the opening area is a maximum of 2 inches. I'm sorry, the opening area can be 10 inches. The penetrating item is a maximum 6 5/8. Annular space shall not be less than 3/8, 10 mm, and then rigidly support the pipe. So shall not be less than. So that means you can go as big as the assembly allows with a penetrating item, taking into account that the maximum nominal opening is 10 inches. Should have to do a little bit of calculating on this one to make sure you've got it right. Looking at another system, this one moves to system 217. Let's go ahead and move on from the FM systems real quickly because the internet seems a bit slow there. Let's go look at another UL system. This one's a curtain wall assembly, and I've done this for a reason. And this one is the CW-S. S is for static, D is for dynamic. The CW-S-2053 gives us an F rating of 2, a T rating of 1/4 hour, with a linear opening width of an 8-inch maximum diameter. Looking at the assembly, we can see there's a concrete panel on the exterior skin. There is mineral wool insulation or some kind of insulation that is anchored to the exterior panel system. Then there's a mineral wool of some kind with a spray of some kind over the top of it. So it's talking about a floor assembly, 4.5 inches minimum, 114 mm, steel reinforced lightweight or normal weight concrete floor, supported at perimeter edges by spandrel beams. In this case, the curtain wall assembly is going to talk about its spandrel panels as a minimum of 36 inches high, a framed window, impaling pins, clutch pin clips, and then of course a curtain wall insulation. In this case, it's the Rockwool Malaysia Curtain Rock 80. But take a look at all the detail that exists for making sure that this system gets installed properly. It's going to talk about the mineral wool board insulation faced on one side with aluminum foil and scrim, vapor retarder supplied by a minimum 24 by 48 millimeter boards, and the boards have to be installed vertically with tightly butted seams to cover the interior surface of concrete spandrel panel. The horizontal seams of insulation boards are to be located a minimum of 24 inches above and 6 inches below planes of the floor. So while it looks relatively easy in the picture, let's take a look at the picture again. Okay, great. We're going to put some insulation up, and we'll have it just installed however we want. No, we can't do that on the vertical surface. It's going to tell us exactly how that insulation material has to be installed. And it's also going to limit the insulation material to rock wool, curtain rock 80. That means that we cannot use thermofiber or other rock wool, mineral wool materials. Only rock wool Malaysia, rock wool can be used for this particular application. Then it's going to talk about the maximum separation between the edge of the floor assembly and the curtain wall insulation is a 6-inch wide gap or breach. The safing system shall incorporate the following construction features. The mineral wool batt insulation safing material is to be cut into 4.5-inch wide pieces and stacked to a thickness that's at least 25% greater than the width of the linear gap between the curtain wall insulation and the edge of the concrete floor slab. The stacked safing material is compressed, inserted cut edge into the linear gap between the spandrel panel attachment plates or tubes. An additional 1/2-inch thick piece of material is used to cover the top surface of each dead load anchor. There's a lot here. I mean, that mineral wool has to be installed a certain way. In other words, the fiber orientation has to be vertical, not horizontal. And then it's got to be compressed. So it's got to be 25% greater than the width of the gap. So that means it has to be compressed, put into the joint, and let it open up. And then the fill void or cavity material would be an 1/8-inch wet thickness, 1/16-inch dry of fill material, spray applied over the top of forming material and lapping 1 inch onto the top surface of the concrete floor and onto the wall assembly itself. In this case, it's a Hilti CFS SP SIL silicone joint spray or the WB Firestop joint spray water-based material as well. Moving on to this other design. This one, again, shows FTL ratings and then shows you the maximum linear opening width. And then also goes into define what kind of movement is capable of this particular application for wind sway at the exterior skin of the building. But take a look at this. Look at the spandrel height. That looks to me like it's 39 inches, 36 inches above the horizontal assembly, which means that the program will pass the ASTM E2307 test standard. Let's see what it says further down in the system. I'm going to talk about spandrel panels, vision panels, perimeter angles, stiffener tees, and then it'll get us right to the curtain wall insulation. In this case, 2-inch thick mineral wool batt insulation faced on one side with aluminum foil scrim, vapor retarder. It's applied in 3-inch wide batts. The stiffener tees and the transom and the insulation panels are to be held up with weld pins. And take a look, the specifications for the separation of the weld pins are all laid out here. Firespan 90 curtain wall insulation is used. It's used for both the insulation and then also for the framing covers. And it talks about the thickness and the width of the product as well. Then it talks about the safing system. The safing system is where the interior safing slot is protected. And it's saying batt sections cut into a minimum 4-inch width, stacked to a thickness which is 20% greater than the width of the curtain wall, and then installed so it's pretty close to being flush with the horizontal assembly, flush with the horizontal assembly. In this case, the thermofiber SAF, and then it's covered with an 1/8-inch wet, 1/16-inch dry of fill material, spray applied over the top of the forming material, and lapping a 1/2 inch onto the top surface of the floor and onto the curtain wall insulation and framing. Spec Seal AS200 safing spray or Fast Act spray can be used. It's important to note that the thickness of material is stated in both wet and dry. You won't find that in the sealant sections. You'll only find it in the spray applied material sections. So we've covered a couple of systems. Let's see if we can take a look at a couple more systems before we move on. Here's some head of wall systems. This system is HWD 0382. It's kind of a unique system. Not really unique. I'd just say it's an average system that you would see on a project site. In this case, it's showing in 1A, 1B, the assembly for the horizontal assembly. 1B is the concrete floor with a fluted metal deck. 1A is the SFRM fireproofing that's been applied to that metal deck. 2, all the way around, is showing you the Firestop system and its components. 3 is going to show you the Firestop spray. Let's take a look at the assemblies down below and see what we've got. Got a steel beam with a beam pocket, if you will. We've got fireproofing on the beam and much, much more. First one is that the assembly, horizontal assembly, is in the D700 or 800 floor ceiling design, including steel form units, 3-inch fluted, concrete floor, minimum 2.5-inch thick reinforced concrete as measured from the top plane of the floor units. And it's going to have a spray fire-resistant material applied to it. That spray fire-resistant material is going to have both of the manufacturers that you would typically find. There's a third one, Carboline, but mostly you see GCP and Isolitech. And note that it's got the type MK6 and type 300. These would be the plaster-looking materials, not the mineral wool-looking materials. Mineral wool would be a brownish color. Plaster would be more of a grayish tan color. And they'd be totally different base materials. Wall assembly, 1 or 2 hour wall assembly, U400, V400 assembly, and then it's going to specify the steel and then also the ceiling runners, and specifies the studs, the spacing, the fastening of that gypsum board to the assembly. Then it's going to talk about the joint system. The joint system is going to have a maximum separation between the bottom plane of the spray applied fire resistant material on steel floor units and the top of the gypsum board assembly. And that space is going to be a 1-inch maximum at the time of installation. Maximum separation between the spray applied fire resistant material, also known as SFRM, on the bottom, the structural support member and the framed opening. The top of the wall is 1 inch. Joint system is designed to accommodate a maximum 16% compression or extension from its installed width as measured between the bottom plane of the steel floor unit and the top of the gypsum wallboard. The joint system's got to consist of the following: forming and fill materials with or without a deflection channel. In the forming material, it's going for a nominal 4 PCF or 64 kg mineral wool, cut into a length approximately 1/4 inch less than the thickness of the wall and inserted edge first into the spaces of the spray applied fire resistant material on the structural steel member and the framed notch at the top of the wall. The thickness of the forming material shall be sufficient to attain a minimum compression of 33% between the sides of the frame notch and the protected structural steel member, and a minimum 33% between the bottom of the frame notch and the bottom of the protected structural steel member. It's recessed 1/8 inch from the gypsum board on both sides, the gypsum board surface on both sides of the wall. And then the forming material is recessed to 1/8 of an inch. What's the forming material? Industrial Insulation Group, LLC, Minwool, 1200 Safing, Johns Manville Safing, Rockwool, Delta Board. And then the fill material, in this case, is a new fill material. So let's get back to our discussion on this. Just know that every one of those parameters has to be followed in the tested listed system design in order to get fire stopping installed in the tested listed system. So while I'm going to talk about products and processes, the real nuts and bolts of this industry are in those tested and listed system designs. That's what the Firestop professional, whether it's the manufacturer, the Firestop contractor workers, Firestop contractors project managers, Firestop contractors estimators, and salespeople all need to know the systems. The Firestop special inspection agencies need to know the systems in order to analyze them. The Firestop authority having jurisdiction that judges the assembly needs to know about the systems in order to judge whether or not they've been done right. The building owner manager should know about the systems in order to buy them properly. All of it revolves around the systems. Unless we can't find a system in the directory from all of the manufacturers in all of the directory, then and only then do we move to a engineering judgment or equivalent fire resistance rated assembly. What's the first action in that process? If we can't find a system, what do? Look in the directory and see if we can find one from any manufacturer. The search feature in the UL Product IQ makes it possible to do this. Let's move this over here and I'll show you what I'm talking about. Sign on to UL Product IQ and then simply scroll down to understand where the systems are. Fire dampers, exterior wall systems, fire door and fire windows, fire-rated roofs, walls, floors, beams, and columns are all listed here in this particular application. Fire-rated roofs, walls, floors, beams for Canada, grease ducts, ventilation assemblies, and then, of course, Firestop systems, joint systems, perimeter fire containment systems. Those are the things that we would be looking for. How do you look around to see if you can find them? Use the search by keyword, by system number, by FTLW rating, and of course by company name. That's how you'd find out whether or not there's a system for this. The other method is to ask the Firestop manufacturer, do you know of another manufacturer that has a system for this? The manufacturers know each other's products and systems very well. Why? Because they compete daily worldwide and they have to know the competitive systems. That's why. Moving on. So when it comes to engineering judgments, first find another system from the same manufacturer. Can't find it from the same manufacturer, find one from a different manufacturer. If no system exists in either application, then find an engineering judgment or equivalent fire resistance rated assembly. You say, like, Bill, what's this EFRRA? We're not familiar with that term. The only term we know is engineering judgment, EJ. The EFRRA was invented 20 years ago by FM Approvals because they felt they wanted to have a term that said what the manufacturer intends it to be. The manufacturers intend it to be equivalent. In other words, that if subjected to a fire test, the engineering judgment will pass that particular fire test. The International Firestop Council, the Manufacturers Association, has guidelines for evaluating the engineering judgments. It says the construction industry professionals and others need guidelines for evaluating and using such judgments. That's why FM wants to call it an EFRRA. When the manufacturer develops an engineering judgment or any other entity develops the engineering judgment, and in our opinion at FCIA, the manufacturer should be involved in all cases, shall be involved in all cases. Why? Because the manufacturer knows the chemistry, they know the boundaries of where these products might fail, and it's important that they're involved. First things first, don't substitute it for existing designs. The guidelines emphasize the importance of tested and listed systems designs. They should be used and based on interpolation of previous testing. That means the engineering judgment has to reflect the parameters that are in the tested and listed system that they're referencing, and much more. So again, back to the process, as I had mentioned, find another system from the same manufacturer. Can't find one there, find one from a different manufacturer. If not, move to an engineering judgment. Let's get on to installation and inspection. Think about the systems that I went through. These are the key questions that need to be asked in order to select from a contractor perspective or analyze from an inspection agency perspective or the authority having jurisdiction building owner perspective. These same questions are used by the building owner and manager to purchase these Firestop systems, because the building owner and manager is not purchasing a Firestop product, they're purchasing a Firestop system. The Firestop system would consist of knowing what the wall and floor construction type and the rating of that fire and wall is. What's the thickness of that wall or floor assembly? What are the penetrating item or the coverings that are used? What's the size, type, and thickness of those penetrating items and coverings? What's the annular space, joint, or breach sizes? And then what kind of packing, damming, backing materials might be used along with the fill materials that might be used. That's what makes a Firestop system installed to the manufacturer's installation instructions and the tested and listed systems designs. So we've been talking for an hour and 15 minutes about fire stopping, and we have just now gotten to where you can see product being installed. And the reason why is because the product installation piece is the second piece of Firestop systems. The first piece is understanding those tested and listed system designs. Without understanding them, going through installing products is a waste of time, period. Without having the tested and listed systems, installation is a waste of time. Yes, we did just say that. And the reason why is because the tested and listed system plus the manufacturer's installation instructions installed properly means that it'll provide continuity of fire resistance of the assembly. Well, it looks like the person is sealing around the penetrating item and having the product touch the wall and the penetrating item. It's not just about, quote, sealing. It's about maintaining protection that's provided by the wall assembly, maintaining the continuity of fire resistance through the breach, such that the complete system becomes the Firestop system, providing the fire resistance. Whether it's at the head of wall joint, the penetrating items, at a fluted metal deck with fireproofing on it, with a conduit going through it, we've got to find the system that matches up to all of these things. Remember when I took a look at the system in CAJ 5029, 5129, whatever that system was, it said that the sleeve had to be cast iron and could extend past the wall 2 inches. Now you're a Firestop professional. Look at this assembly. Is that Schedule 40 sheet metal sleeve? Is it one? Doesn't look like it. It looks like sheet metal to me. Is the sheet metal sleeve extending 2 inches past the assembly, or is it more? It looks like it's more to me. Where is the Firestop sealant installed? In some cases, the penetrating item, or let's see, the Firestop system will be needed to be installed at the plane of the wall assembly instead of at the end of the sleeve. The system will tell us that. So the Firestop systems are nothing but, they're not easy. They are complex. It takes, it's not impossible to learn them, and people can learn them, but it's got to be known that the Firestop system has to be followed verbatim. When it comes to fire dampers are tested to a different test standard, UL 555 and 555S. They may or may not have had a Firestop system installed at the time of fire testing in order to provide that hourly fire resistance rating. The fire dampers have the listing incorporated in their manufacturer's installation instructions. That's not true in fire stopping. In fire stopping, it's a separate listing and then a separate manufacturer's installation instructions. If Firestop sealant is going to be installed anywhere, anywhere around this assembly, for instance, around the angle that you see around the perimeter, then it's got to be allowed by the fire damper manufacturer, the Firestop manufacturer, and the authority having jurisdiction. A lot of products have been invented for the Firestop marketplace. Firestop sealants, silicone, latex, intumescent latex, wrap strips, thin, thick, wide, less wide, putties, pillows, composite sheets, bricks, plugs, prefabricated kits, mortars, spray products, and tapes. The manufacturers have been amazingly creative in finding ways to have Firestop products that meet the needs of the environment they're going to be exposed to. We compliment them, we applaud them. But installation is a lot more than just taking the product and installing it. It's about understanding where the fire resistance rated wall or floor assembly is. It's about understanding which Firestop product gets used in which system, and then understanding the manufacturer's installation instructions. Currently, the way fire stopping gets installed is that he or she who pokes a hole, fills it, is one method for installing fire stopping. General contractor allows anyone that penetrates, creates a breach and then penetrates that fire resistance rated assembly with a penetrating item, they would install the fire stopping. Just know that it's difficult for any worker to understand one trade, let alone all of the trades. In other words, all of the construction disciplines. Construction disciplines meaning wallboard, penetrating items, and fire stops. That's 3 basic construction disciplines to understand. Difficult to be a master of one, let alone a master of 3. And fire stopping is a construction discipline all and of its own. The second method is there's a multiple contract provided. Those that poke the hole and then fill it, and there might be a specialist Firestop contractor on the project site. The final method is the Firestop Contractor, the Firestop installation contractor. Covers all fire stopping. In other words, installs all fire stopping as a separate contract to the general contractor to make sure that they get fire stopping installed in tested listed systems. What happens when those contractors don't get hired? Here's what happens. Disrespect for fire stopping. Using packing tape instead of the fire stop tape. Using towels instead of pillows. Using foam that's been tested at ASTM E84 and not ASTM E814. ASTM E84 reaction to fire, ASTM E814 fire resistance. Leaving breaches open without anything in them. Installing collar kits upside down and not fastening them to the wall. No fire resistance provided by these installations. Installing a scab patch over the top of a wall and then putting some pink tape around it won't provide fire resistance. In the front of the UL directory, the UL guide information, it says that the Firestop products from one manufacturer to the next are not supposed to be mixed between 2 different manufacturers or between 2 different products. They're supposed to be as installed as is tested and listed. There are no tested and listed systems with one manufacturer touching the other manufacturer's products, and this should not happen. Nor should this, where a plastic penetrating item going through a gypsum wallboard at an angle has red sealant and then mineral wool all over it. Or these things. Breaches with wallboard compound won't last at all. So what happens when a non-skilled Firestop installer installs? Exactly what I showed. There are many in the industry that look at fire stopping as a joke and don't believe in it. It's serious business. It's a serious application, and it needs to be paid attention to. What happens when fire stopping is installed wrong or it's missing? A life safety risk results. What about systems documentation? To these rocket scientists that you see on the right-hand side, actually I call them the Cirque du Soleil of fire stopping, the gymnastics guys and ladies that are climbing on top of people's shoulders and spray painting stuff. Do you really think they're using those tested and listed systems we just spent the last hour or so working on together? I don't think so. Will they provide the proper as-built documentation? I don't think so either. Do they know what FT, LW, and M readings are? No, I don't think so. Do they know the zero tolerance that's required, such that if the system requires a L rating, because it's a smoke barrier and the system has to have an L rating, do they know what the heck that is? No. They know firecaulk and installing it. So how do we get around that, or how do we find qualified companies that understand and have a culture of quality? FM 4991 UL qualified contractors know what that is. Other industries don't have this yet. The Firestop industry leads with third-party accreditation programs, the UL Qualified Contractor Program and the FM 4991 program. What do you get with that? You get it built right the first time. You get documentation that results in an inventory of fire resistance that's required by the International Fire Code. You get systems that have been analyzed and installed to the manufacturer's installation instructions in the systems. How do companies get to be UL qualified, ULC qualified, or FM 4991? Somebody at the company passes a Firestop exam with a minimum 80% passing grade. The company has a management system. In other words, how do they get Firestop systems selected? communicated to the field, the product to show up that is appropriate for the listing and meets the listing, and then installed to the limitations of the tested and listed system design, documented, systems returned to the office, and then the office project management communicating through the construction communication channels to the building owner, the as-built documentation, including systems, and then also the manufacturer's installation instructions and maintenance instructions. That's what a management system does. The UL and FM people then audit the contractor at the office and a job site, and then the person that passes the exam becomes the designated responsible individual. You find these companies listed at fcia.org and also at ul.com or FM Approval Guide. You'll find them there as well. What's a management system? Well, the management system has a lot of things to it. The steps that are used, first and foremost, is that the UL or FM personnel have a walkthrough, a facility tour, to find out what is it that the company does. They then review the management system manual to make sure there's no deficiencies in that management system manual. Remember, the management system manual is going to cover a lot of stuff, and here's what it is. The management system manual has to say what the contractor uses for its construction document requirements and review. In other words, review the construction documents. That would be the life safety drawings, the specifications, the manufacturer's installation instructions, and the listings to make sure the systems have been selected that are appropriate for that particular application. It's got to be a procedure for procurement of the Firestop materials. How does that manufacturer supply, and then how does the contractor buy it? Not really covering price, but it's covering the services. Do the products arrive at the project site as specified? Are the containers in one piece, or are they broken? That procurement process has to be written down by the Firestop contractor and then followed. Then what about storage, handling, and delivery? Does the Firestop contractor store the products as recommended by the manufacturer's instructions? Some of the materials are required to be stored at 40 degrees, between 40 degrees Fahrenheit and 90 degrees Fahrenheit. What processes does the contractor have to make sure that takes place? Some materials can freeze. Some can freeze a few times. Some can freeze not at all. It's all part of storage, handling, preservation, and delivery. Also in storage, handling, preservation, and delivery would be shelf life issues. How is the shelf life of that Firestop product understood by the workforce so they don't use expired material? And then how do you rotate the stock to make sure that that material is fresh? Labeling. FM approvals, if an FM label has been specified by the building owner manager or specifier, it has rules for those labels. It says to install them 6 inches away from the penetrating item. And also has the FM mark on it. Then what about installation, application, and field quality assurance procedures? Those procedures have to be outlined as to how that contractor competitively installs those Firestop products. And then what kind of self-inspection is done by the contractor along the way. In the inspection, testing, and calibration section, the UL Qualified Contractor Program, the FM 4991, is not looking for an ASTM E21742393 inspection. It's looking for enough self-inspection by the Firestop contractor to make sure that their management system is working and that the installation quality stays at top shelf. What about testing and calibration? The calibration is basically the measuring tapes and the machinery used to install the fire stopping. Machinery would be the spray products that are used or the spray pumps used to spray fire stop materials, and then also the caulk guns and the tips that might be used to make sure that the product gets placed to the right spot. Tape measures are the biggest thing to calibrate. How do you do that? Are they visible, legible? Are they bent or broken? If they are, they might need to be fixed. Finally, next up is non-conforming product. So under storage, handling, preservation, and delivery, you might have a procedure that talks about non-conforming product upon acceptance at the project site, whether it came from the warehouse or came from the manufacturer or the distributor. And then once it's on site, you have to be sure that the products that have been expired either get renewed by a manufacturer documenting that the product can be used continually past its expiration date, or a disposition of some kind has to be laid out for that product as well. Is it isolated, marked, and then made sure that the product doesn't get used again? One of the big things that's part of the program is the training of the workforce and the staff. This training has to result in a culture of quality, Firestop installation quality, from the estimator, project manager, superintendent, foreman, and workforce, all the way along, including the office staff, the president and vice president of the company. All of the levels of the company need to have the same culture and the same installation thought process when it comes to installing Firestop systems. When it comes to corrective and preventative actions, the Firestop systems that have been installed wrong, how do you correct it? How do you find it? That would take place during the inspection, testing, and calibration. So dropping back to do self-inspection would be a way to protect and make sure that there's corrective and preventative actions. What about the quality system monitoring and improvement? That management system manual has to be reviewed from time to time to make sure that the process works properly. Finally, documentation. Firestop systems documentation has to be kept for 7 years according to both programs, the FM program and the UL program. UL has come up with a new program also, in addition to the Qualified Contractor program. That program is the Master Audit Certificate of Compliance, or MAC as they call it. It's a job site specific management system audit that provides an audit by UL that the processes were followed on that specific project site, and then winds up with a certificate of compliance from UL to the building owner and manager that's offered through the contractor to the building owner and manager. It's annually renewable every year. That helps the building owner and manager meet its requirements in the International Fire Code as well. What's the result? A Firestop contractor that installs products to the tested and listed systems, maybe even marks them with labeling, and understands the products have to be installed to the listed systems and the manufacturer's installation instructions such that they comply with the building code and fire codes that are in the location that the products have been installed. Quality installations from quality contractors are a big deal. Part of the DIIM is also inspection. The International Building Code, Nfpa 1, and other codes have inspection required to the ASTM E2174 E2393 inspection standards. The ASTM E2174 2393 outlines the inspection process. I put this picture up on purpose because it shows a inspection cut, if you will, into the Firestop sealant in a triangle form. The International Firestop Council has a procedure for inspecting Firestop sealants that have been installed to the manufacturer's installation instructions and the tested and listed systems. And it says that the thickness of Firestop sealant shall be measured at the bond line where the Firestop sealant touches the penetrating item and the floor or wall assembly. For joints, it would be both horizontal assemblies and then also wherever the product touches the inside of the joint assembly, if you will. Why? Because the products shrink. Latex sealants can shrink up to 20% of its original state. Silicone sealants can shrink a percentage of its original state, but not that much. Urethane sealants will also shrink. The only ones that don't shrink are typically the two-part sealant products that form a different type of chemistry. The silicone foams won't shrink on installation. They'll all actually expand 3 times their original state once they're installed into an area. So it's important to know that the inspection options that are available in the marketplace today are the contractor doing some of their own, not necessarily the 2% or 10% of the applications. Manufacturers do not inspect, but the 2174, 2393 inspection standards have both destructive and non-destructive methods. That's what's in the building code. That's what should be done for inspecting fire stopping when it comes to the International Building Code and the requirements for that particular application. Other scopes don't necessarily have inspection required for them, although if you think about it, fire dampers have to be commissioned. That means they have to be tested at installation, 1 year after installation, and then every 4 years in most occupancies, every 6 years in healthcare occupancies. Fire-rated glazing, no such inspection at installation. Fire-rated wallboard, no such special inspection for that either. Fire-rated doors has an annual visual inspection required by Nfpa 80, which is where you would find the requirements for fire doors, fire dampers, fire-rated glazing, and of course rolling and swinging doors as well. Nfpa 1 has some requirements for installation and inspection. In Nfpa 1, it talks about a quality assurance program for the installation of devices and systems installed to protect penetrations of joints. It has to be prepared and monitored by the registered design professional. In our opinion, that quality assurance process is the FM 4991 UL Qualified Firestop Contractor program, and then, of course, the ASTM inspection standards. Then, down in 12321 of Nfpa 1, it calls for 2174, 2393 inspection. Why? Because the FCIA worked with Koffler & Associates to have that listed. The International Building Code, Chapter 17, requires that ASTM E2174 2393 be used as well. And it has definitions. It defines the approved agency. That would be the agency that inspects the fire stopping. An established and recognized agency. And the approved agency is approved by the building code official, and the inspector is also approved by the building code official. The special inspector would be the employed or retained person retained by that approved agency. And then back again, the approved agency is an established and recognized agency that conducts tests or furnishes inspection. So there's two approvals that the building official has to do before they can even start thinking about special inspection to the tested and listed systems using the 2174 and 2393 standards. The FCIA was the proponent to add ASTM E2174 to Nfpa 1, Nfpa 101 and 5000 to mandate it in the International Building Code 2018 for buildings 75 feet and higher over lowest fire department access, occupied floors 75 feet and higher above lowest fire department access, and then also occupancy type 3 and 4 in table 1604.5. I'm not going to spend a lot of time on that occupancy chapter. Just know that when you see special inspection, it's going to cover a lot of different types of buildings, as you can see here. Assemblies, elementary schools, power generating treatment sections, hospitals, rescue and ambulance police stations, power generating stations, and utility sections as well. There's a long list of buildings that require ASTM E2174 and 2393 standards. Once the standards have been mandated, there are qualifications for the inspection firm that have been written into the ASTM E2174 2393, but not a lot of specifics. The things that it says is that the inspection firm shall be independent of and divested from the contractor and the installer. Why? Because there could be a conflict. If the competitor of the Firestop contractor inspects the fire stopping and they lost the project to that competitor, guess what? The inspection just won't be fair. That's why there's an independence clause in the ASTM E2174 2393 standards. It also exists in the International Building Code. The inspection agency is to submit notarized independent notarized statements stating no conflicts exist. Then the building official has to decide whether or not there are conflicts. That's part of their approval process. The second thing is the agency has to be looked at. One way to evaluate the agency and know that the inspectors have some kind of qualifications is to specify the IAS AC291, the International Accreditation Services IAS AC291. That means that the company, the inspection agency, has a management system similar to what you saw for the contractors, audited by International Accreditation Services, and has individuals that have passed the FM or UL Firestop exam, or also the International Firestop Council exam as well. It's got to be specified. It's not something that you would find that's mandated, and nor are the FM and UL Firestop exams. Nor is any certification required. The inspector, all they have to be is independent and have competency in the same type and complexity of inspections that have been done. There's a pre-construction meeting that's part of the 2174-2393 process, and it's also in the FCIA Firestop Manual of Practice. Review the documents, review conflicts, figure out if there's any issues, review the specifications, the manufacturer's installation instructions, and of course the listings and the safety data sheets. And then during that pre-construction meeting, there should be a mock-up built of all the Firestop systems that are going to be used, and then them evaluated by the inspection agency so that the contractor understands what the inspection might look like. The inspection schedule is such that the contractor, the installing contractor, Firestop installation contractor, informs the inspector that there's some inspection that will take place and that they've got 2 days notice so that they can plan to get themselves there. The inspector's job is to verify the installation, that it complies with the installation instructions from the manufacturer and also the tested and listed systems designs. Those are the two pieces that have to be covered by the inspection agency. How do they do it? 2 ways, observation and destructive testing. Under the observation method, during construction, that the inspector randomly witnesses 2% of each type of penetration Firestop system, no less than 1 per 10,000 square foot of floor area. And in FCIA's opinion, that type is by Firestop system, by contractor that it's installing that Firestop system. That's a critical point to remember for our inspection friends, is that all the Firestop installation contractors installing products are to be inspected on the project so that nobody misses an inspection. Conceptually, if it's not done that way, there could be several contractors that never get an inspection because they're all using the same Firestop system listing, and only one of them gets inspected. Under the observation method, 10% of each type of penetration, 5% of each total lineal feet of each joint system is done, and again, by system, by contractor for the joints as well. For destructive testing, same concept. The only difference is destructive testing is 2% of each type of Firestop installed per 10,000 square feet of floor area, 930 square meters, no less than 1 for each 10,000 square feet. And then as far as the destructive testing for joints, the mechanical joints don't get destroyed because they've been installed and would be, they're permanently installed and would be too onerous to inspect them destructively. The inspection documents that are reviewed and that are used by the Firestop Special Inspection Agency have to have the manufacturer's installation instructions and the listings. It sure does make it easy for the Firestop contractor if they've got the labels that identify the Firestop system, so that way the Firestop Inspection Agency can quickly identify what Firestop system it is and evaluate it based on that system. Variances, the Firestop contractor has to be notified within 1 day of any deficiencies based on the ASTM standards. Based on the International Building Code, it means immediate notice of any deviations. In today's world of mobile phones, the Firestop Inspection Agency can call the contractor right away and notify them of the deviation. So it's not impossible to do something like that. If there's deficiencies and they're reported to the contractor, If the listings are there and the installation doesn't conform to the listing, then it's rejected. If there's 10% or more variance for every type of installation, the inspection stops. The inspection stops completely. The installer re-inspects their own work, then calls the inspection out, and then it's subject to one additional inspection for each of those types. All deficiencies have to be documented. Key things about the inspection agency: they can't supervise the workers. That means picking the system. They can't coach the workers. They can't coach the worker into another system. That's the contractor's responsibility. That's where the immediate notice to the contractor for deviation comes in. That would mean that the Firestop contractor employee supervisor has to get to that project site right away and fix the application. The idea of this is that the Firestop contractor that gets it and understands systems isn't going to have much in the way of rejections and will get the installations done quickly. The inspector's equipment: measuring tapes, tablets with the systems, or laptops with the systems on them, but not micrometers. Micrometers are not used for soft Firestop sealants. They're used for hard things like mortars. They can use them for mortars, but not for soft sealants. Finally, the evaluation is done based on the Firestop system only, based on the thickness of sealant mentioned in the Firestop system, the thickness of backing material, the annular space size, the penetrating item size, and then also the manufacturer's installation instructions, and that's it. It's not a qualified type inspection. In other words, it's got to be quantified, verified by quantified facts, by the listing, by the manufacturer's installation instructions. When it comes to repairing, Firestops have to be repaired to the manufacturer's repair instructions to make sure to maintain the FT, M, and W ratings. Inspection forms are provided by the inspector, minimum of one form for every type of Firestop. Every type is by system, and they've got to be submitted to the authorized agency. In other words, the agency that hired the Firestop inspector at a maximum of 1 day after the review. And again, immediate notice if there's problems. The final report has the project name and location, the team contact information, the Firestops that were reviewed, type, quantity, method, percentage of deviations and deficiencies, all submitted to the authorized agency. And then again, the repair method is stated as well. Now let's talk about barrier management and maintaining protection, if you will. Nfpa 1 and Nfpa 101, the International Fire Code, have requirements for maintenance. I'm going to go through these relatively quickly, but I want you to see that the consistency between codes is very apparent. And what it says is that fire-resistant construction required for compliance shall be thereafter continuously maintained. Can't be removed if it's obvious to the public. It cannot be reduced if it's required by the building code. And then take a look at the middle. It says shall be tested, inspected, or operated as specified in the code. And then finally, the inspection shall be performed under the supervision of a responsible person who shall ensure that the testing, inspection, and maintenance are done at specified intervals. So the supervision of a responsible person, that person has to understand all the different types of fire resistance that are required for buildings. Nfpa 1 also has requirements for fire resistance in buildings. Those requirements are stated in Section 12 of Nfpa 1. Nfpa 1 talks about in 12.3.2 the quality assurance procedures. We talked about that earlier. In 12.3.2.1, it asks for ASTM E2174239 standards. It also mentions, and this is the charging language that you really should know for all types of the fire codes, that the fire resistive construction, that the fire resistance rating for all of these types of assemblies shall be maintained, properly repaired, restored, or replaced where damaged, altered, breached, or penetrated, removed, or improperly installed. And I'll spend time on that improperly installed. That improperly installed really means that the building owner is responsible regardless of whether they think it was installed right or not. So therefore, the building owner and manager, if loss of life, loss of property takes place, the building owner and manager cannot blame others for that issue because they're responsible for improperly installed fire stops and other fire resistance items. And then where gypsum wallboard has to be replaced or protected, it's got to be equivalent to the tested and listed system and the repair system that's there. The person responsible for doing the annual visual inspection or visual inspection as conducted at the frequency in Nfpa 1 has to have technical knowledge as well. International Fire Code, since the early 2000s, has had this same type of language that you would see in Nfpa 1. Elements visually inspected by the owner annually. Properly repaired, restored, replaced when damaged, altered, breached, or penetrated. Records shall be maintained. That's pretty amazing stuff. 2018 International Fire Code broke all the different construction disciplines that are involved in fire resistance into various sections. The sections include structural fire resistance, fire dampers, fire-rated doors, both rolling and swinging, fire stopping, fire-rated glazing, all broken into separate pieces to bring respect to fire resistance in existing buildings. 701 lays out the scope that the inspection and maintenance of the materials, systems, and assemblies used for structural fire resistance and fire resistance rated construction separation of adjacent spaces, so two different items. Protection of the structure, spray fire resistant materials into tumescent fire resistant materials, and then separation, that would be compartmentation. Fire dampers, fire doors, fire glazing, fire stopping, and the wall itself. Six-sided box. That these assemblies have to be maintained and visually inspected annually. Here's the section 701 that gives you the pieces, if you will, and then it goes through various items. The smoke barriers and smoke partitions all have to be maintained. But look at the title of this section, 701.5, Maintaining Protection. So products, some of the products, do not require maintenance according to the manufacturer, but the protection needs to be maintained. If a new penetrating item is run through a breach in a fire resistance rated assembly, it's going to change the fire resistance rating of that assembly, and therefore the protection might not be maintained anymore because the system changed. That's why the protection has to be maintained. In 701.6 of the 2018 International Fire Code, brand new section says that the owner shall maintain an inventory of all fire resistance rated construction and construction installed to resist the passage of smoke, and then also the construction in 703 through 707, that's the fire dampers, doors, fire stopping, fire rated glazing that we talked about earlier. Such construction shall be visually inspected by the owner annually and properly repaired, restored, or replaced where damaged, altered, breached, or penetrated. Again, an FCIA initiative in the yellow to have an inventory. That sets up the documentation needed so that the visual inspection by the building owner or the building owner's agent, whoever they hire to do that, a barrier management services contractor, a special inspection agency, or other agency, to verify that the Firestop systems have been installed, the tested and listed systems, and are still there. Records need to be maintained of the repairs as well. And the fire official now has the ability to ask for those repairs. If the building official, or fire official deems that the maintenance has not taken place, that there's no protection, fire resistance protection, in their opinion, they can deem it an unsafe condition and order immediate evacuation of that assembly. Imminent danger is what it's called. So the maintaining protection is critical for fire stopping, for fire resistance rated assemblies. And where the system design number is known, the system's going to be inspected, visually inspected, to the listing criteria and to the manufacturer's installation instructions for both the penetrations and then also for the joint systems as well. One thing that's key to remember is that the retroactive basis for the fire code only means that the fire resistance needs to be maintained. It doesn't mean that if the existing fire resistance was installed in 1950, and it seems continuous and maintains protection as required in 1950, it doesn't have to be torn out and put a new fire stop system put in. That wasn't the intent of the fire codes in that particular application. The 701.6, I want to bring it up one more time, that the owner shall maintain the inventory. I talked about the inventory at the beginning of our program. At the 078400 and the 017839 specification, those two need to talk to each other and refer to each other. In other words, in Division 1, it has to refer to Division 7 of the specifications for the manufacturer's installation instructions and the listings. Same thing for fire doors, fire dampers, fire reglazing, and the wall or floor itself. What's needed for that inventory? Life safety drawings, test and listed system designs and their assemblies, the manufacturer's installation instructions. Keep them either on paper, spreadsheets, software, whatever. As far as the annual visual inspection, that's a survey. The FCIA has a recommended professional practice for survey that can be used for surveying existing buildings. What's it look like? It means that the systems seem to comply with the tested and listed system, the system that was installed, that is. Annular space seems to comply. There don't seem to be visual breaches, unless the listing allows for it. Some of the open path devices have openings that are allowed to exist, even though it maintains its 2-hour fire resistive construction. And then check the penetrating item types, the coverings, the number and the quantity of penetrating items, the joint widths, and then also all of the other information that we covered earlier to see if it complies with the listing. And it has to be done by technical personnel that have technical knowledge. What do? They look at all these questions to make sure that the fire stop that's installed matches the tested and listed system design in the as-built documentation. Our building owners and managers, we certainly hope that they maintain a budget for maintaining their fire resistance. They do it for sprinklers, they do it for the alarm system, they do it for emergency fire drills every year. Now we have to convince the building owner and manager and the culture of building owner and manager that fire resistance needs to be maintained for the life cycle of the building, as we had mentioned on and on and on. So in our 2 hours together, we've covered the proper DIIM, proper design, installation, inspection, and maintenance of fire stopping, the specifications, codes, and standards, the management system programs, FM 4991 UL Qualified Contractor Program, the inspection to ASTM E21742393, and hopefully those inspectors have qualifications and have competency by taking the FM and UL Firestop exam and the International Firestop Council exam, and that the management systems, the barriers have been maintained by the building owner and manager throughout the life cycle of the building. So that covers our 2-hour program. Questions, reach out to us at info@fcia.org. And at this point, I'm going to go back over to the questions and cover as many as I can for as long as we can go. So let me take a look at the questions real quick over on our control panel and bring them up so that I can answer them for you as well. So let's get to the questions. First question, can I give an example of a static curtain wall system application? Where can it be applied? That's a good question. That's the reason why there are dynamic curtain wall assemblies. Static was what was developed first, and the only way a static design can be used is if it's absolutely certain that there is no movement between that exterior curtain wall assembly and the horizontal floor assembly. There will be absolute sway of that building, separation between the curtain wall assembly and the horizontal assembly. Next question. What if the fire damper is outside the barrier, 12 inches away? Will the duct have to be fire stopped through the wall even if it has a damper? Great question. The manufacturers of fire dampers make fire dampers that have out-of-wall designs. I don't know how far out away from the wall they can go with their prefabricated fire damper assemblies. If the distance between the fire damper away from the fire barrier or fire resistance rated wall assembly is further than the tolerance allows in the tested and listed system, then it's time to get with the manufacturer of the fire damper and manufacturers of products that protect fire dampers, the ductwork itself, to see what kind of fire-rated wrap might be required for that application. Maybe it's a ceramic fiber insulation with a certain density and thickness. Maybe it's a endothermic matte material. Maybe it's a mineral wool material. Whatever it is, it's got to be something that has passed the tested and listed system for that. So thank you. Really appreciate you asking that. Next question that came up is, how do I get a PDF copy of the FCIA Firestop Manual of Practice? Best way to do that is email info@fcia.org or visit the fcia.org website, and you can request it online as well. The Firestop Manual of Practice is offered free to authorities having jurisdiction. It's offered free to specifiers with design firms, specifiers with independent practice. It's offered for free for those entities. Others, Firestop inspection agencies, Firestop contractors, pay for the document because they earn a living from the industry and should be investing in their career. Looking for further questions. I don't see any further questions going in, so it looks like covered them all. Questions going once. Questions going twice. Questions going 3 times to our audience. Either type them into the chat or type them into the question box. Questions going once. Questions going twice. Okay, next question is, if I have a DRI certificate, in other words, if you have a certificate that you passed the FM or UL Firestop exam, can that transfer to another company if you have your learning units? So the answer to that question is both FM and UL will allow transfer of your certification that you've passed the UL or the FM Firestop exam. They'll allow that to take place as long as the company that you left signs a certification that they will let you have that certification. If they don't let you have it, then there's no way to have that happen. So what has to happen is you contact FM or UL. If you don't have the contact persons, email us at info@fci.org and we'll get you that information, and then we'll pass on to you the appropriate personnel. So good question. Next question. Oh, no question yet. When is the next FCIA exam, FM and UL exam in the Middle East? Good question. I can tell you that we do FM and UL Firestop education, or FM and UL Firestop exam education. The exam can be taken by inspection agencies or Firestop contractors. And what we do is we offer a 4-hour education for anyone that wants to be part of it that's an FCIA member. And then the UL offers their exam online for you to take. FM does not currently have that option, but they are definitely looking into it, and we hope to see something here shortly. So you can take that exam from UL at your convenience. Look for another education sometime in December from FCIA for that exam. Next question. Is fire stopping required at the base of a wall, say a metal stud and a gypsum wall board at the joint with the form? Some forums note that this is less crucial due to the smoke and fire raising upward. Let me see if I can bring over the UL product. Let's see, I can't quite get to that right this moment. So let me answer the question this way. Fire resistance is continuous from floor assembly to floor ceiling assembly above. The minute there is a gap between the gypsum wall board and the horizontal assembly, it needs continuity applied to it. That would be a Firestop system at the bottom of the wall. The horizontal assembly is not tested with a wall on it. The wall assembly is not tested as part of a floor assembly, or with it meeting a floor assembly. Let's get back to the tested and listed system. Let me go backwards a bit here and go from there. Let's go back to the picture that I had of the fire test. So looking at the picture of the fire test, I believe I had a picture of a wall assembly. Maybe not on this presentation. I don't know if I had the wall assembly itself. There it is. Well, imagine, if you will, that this wall assembly is applied to a furnace. It doesn't have a bottom wall joint on that, so it's not tested that way. The ASTM E814 UL 1479 for the bottom wall assembly shows continuity of that fire-resistant rated assembly. Is that the least likely place that fire or smoke would breach the assembly? Yes. Was it tested that way? No. Without any fire stop there? No, it wasn't. Therefore, it's required at the base of the wall assembly. Good question. Thank you. So, a couple of things here. The FCIA really appreciates those that attend these FCIA webinars from wherever you are in the world, whether it's in England, Dubai, Doha, Jeddah, wherever it might be, India. We're so glad that you're part of these sessions. Know that membership is open to all worldwide. FCIA members come from all parts of the earth. They come from Australia, they come from Brazil, they come from Central America, North America, Europe, all over the place. So we appreciate those that have joined. If you're not a member, we certainly hope you will join, because it's your membership dues that help us pay for what we do to provide this education. So a big thank you. As a non-member, you have access to anything that we have here, but it costs you more money to have access to those things. Consider your companies joining the FCIA to get access to those documents. So I'm looking up to see if there's further questions. I don't see any further questions coming in. So again, questions going once, questions going twice, questions going 3 times. Not seeing any further questions. So at this point, I'll wish everyone a great rest of the week, a great weekend, and wherever you are and whichever holiday you celebrate. Some in India going on now. In North America, we have our holiday coming up for next week, and then certainly the rest of the world has holidays as we celebrate things coming close to the new year. A big wish for a great holiday season to you and yours wherever you might be. Thank you for being part of this webinar. I really enjoy the opportunity to provide them to you. I certainly hope they provide value for you, and that somewhere in your life you'll pass this on as I have passed it on to you. Have yourself a great week, great weekend, great rest of the year, and we'll see you on our next webinar sometime in December. Thanks, everyone, and we'll look forward to talking again soon and seeing you soon.